85, from 83 or 85, the Motorola had commercialized their first cell phone. So what do you need from a cell phone? The first thing, that it is portable. You can put it in your pocket. And it is physics that the size of the circuit is inversely proportional to the square root of the dielectric constant of a material. When you need to cook tea and you want to use less sugar, small amount of sugar, you need sweeter sugar. The same thing is here, that if you want to make a component smaller, the property should be enhanced. More polarization is there, polarizability is there, that will increase the dielectric constant, and increasing the dielectric constant will decrease the circuit size. It will make it portable. Second thing, that when you are communicating with it, your signals are not lost, and loss is measured by LCR meter for that purpose. That how much oscillation, if you have a perovskite solar cell, ABO3 type structure, and you substitute some other ion for B, you giving it more room or less room? Is it more polarizable or less polarizable? So you can engineer, you can tailor the material according to your specific application. Another important property is that it works at different temperatures, and for that you measure the temperature coefficient of resonant frequency. The temperature coefficient of resonant frequency. So dielectric constant, loss, and temperature coefficient of resonant frequency. And these three properties brought your wireless set from the lorry to your pocket. And the distance is less than 50-60 years. So today, if you start something, if an illiterate person starts something in his shop, encourage them. Tomorrow they will make something very great. Right? Another example I usually give to my students, that this laptop in front of me is Hewlett-Packard. You look around and you will see many products in the modern day room in Africa, Asia, Europe, Americas, wherever you go, you will see Hewlett-Packard products. Right? Who were they? They were two desk fellows. Hewlett and Packard were two desk fellows, and they thought that we can make this thing, we can make this thing in Stanford University. And today, it is a global company with billions of dollar assets in all the continents of the world. So this classroom is the game changer. Rolls-Royce, the most prestigious car on earth. It was made by Rolls, who was just an engineering graduate, and Rice was a plug seller in Manchester Back Street. And they came together, and the world popular most rocket aeronautical engines are from them. The world best products of aeronautics are from them. And they were just one illiterate technician and one just graduate engineer. In Britain, 0.0001% people cannot hardly afford Rolls-Royce car. It is so prestigious car in the world. And they were developed by so the people who changed the world, who made the world, who transformed the world, are ordinary people like you and me. And we should think, what can we do in this direction? So the scientist cannot make a flying car. They made aeroplanes, But it is not possible for everyone to purchase an aeroplane or fly in his or her car. But functional material has opened new ways and avenues to communicate, connect, and automate our lives. Smart, no need to check the weather before you get dressed. Your own clothes will respond to that. This is what the future looks like. The future, what you have today, is the product of the mind of the people 50 years ago. And what will be tomorrow is the product of your mind. Do you want the world to be like that, or you want to change it? Then think and start working. Tomorrow, maybe you will not see these lights. You will not see the air conditions in this room. Maybe these walls are electrocaloric. That when sun falls upon them, they will turn the material cooler and the room will be cooled down. Your clothes will respond to the sunlight and they will change the weather. Maybe you don't need buildings. A single person can manage himself or herself in their own dress. Are you ready for that smartness? Can you do that? If you are smart enough, then you will climb that bus. And if you are not smart, you will be left on the road. Think over it. The future is more smart, or you can say smarter. And take an old man of your area to Japan or Britain or America. The bus will go and they will be left on the road today. So think about it. That should we be the people laying on the road, or we should be the game changers and the leaders of the modern world? What is smartness? Let's, yeah, this is what I show you, students, that is sea sand, silica, SiO2, sugar, the whole of the scene sugar, right? If you have no technical hand, then it has no value, right? If you can process it, heat it, you can make it into those small balls type things and kids will play with it, right? If you are a little bit more technical, you can make glasses, weaving glasses and different things from them. If you are more skilled, then you will make car screens and different things from that silica. If you are more skilled than that, then you will make fiber optics and different things from that. And you move on up to the microscopes. And what I have written, yes, we خدای لاس په درکړي دي پردې ګوټ پکې او کنه fiber optics په جوړه. This is your choice, right? Smart material, what is smart material? I am making things simplest so that you understand that these are not difficult things. They are the easiest things. Smart material exhibit smarter behavior. Smart behavior occurs when a material can sense some stimulus from its environment and react to it in a useful, reliable, reproducible, and usually reversible manner. A small wire is injected through your leg. It reaches your brain. And when it reaches the desired place, it has its original shape in memory and then rounds up there. and fill the damage in the brain vein. That is called smart material. Every material does one thing. If I hit this table with my hand, it hurts my hand. But if then it can come back and respond, then it is smart. If it is not, then it is not smart. I am looking at the sun and my eye closes automatically. This is smartness. If I see the sun and it hurts, this is not smartness. But if it reacts, the second step, it is smartness. And the modern world that is coming is the smarter world. And smarter world will need smarter materials. Yes, I told you that I'll come back to carbon. So carbon is 25,000-year-old element, one of the oldest element, right? Man used it because of its softness to write on the wood, right? Because of its softness. When men learned to make steel, then steel could not be cut with iron. And then the same carbon came to help. And the diamond saw the diamond is 100% carbon. And that carbon helped him. After some time, the people thought that carbon has done a big job. 25,000 years old means that the mankind knew carbon for the last 25,000 years. But the Nobel Prize in 2010 was given on graphene, which is also 100% carbon. This means that 25,000 years world could not discover the abilities of carbons in 25,000 years. And it is still explored because when they got the Nobel Prize in 2010, they established an institute named Graphene Institute in the Manchester University. And all over the world, the work started on carbon. And it is a single atomic layer. And 1 kilogram is enough. 1 kilogram of graphene sheet is enough to cover a 12 square mile area. So it is atomic level, thin layer of carbon. And all the world is now after graphene. What does this mean? This means that the mankind, despite having millions of years history, has not yet discovered a single carbon. So who says the world is saturated with research and everything has been done? Nothing has been done. The mankind has not learned a single element yet. So think about the universe around you. It is a big treasure. It is very rich. It is very generous, but it needs your hard work and your mind. That if these two are with you, you can change the world and you can lead the world. This is the graphene sheet.